In this highlight video, we are going to introduce reduction and oxidation reactions. After watching this video, you should be able to identify reduction and oxidation reactions of organic substrates and also be able to recognize common reducing and oxidizing agents. In general chemistry, you learn that oxidations involve the loss of electrons. For example, the conversion of iron 2 plus to iron 3 plus involves the loss of an electron. Reductions, alternatively, involve the gaining of electrons. So, for example, fluorine can be converted to fluoride by gaining electrons. Now, in organic chemistry, carbon atoms often have multiple oxidation states, and so calculating loss and gain of electrons can be challenging. So we take an easier strategy. In general, in organic chemistry, oxidation is going to involve either gaining oxygen or losing hydrogens, whereas reduction will be just the opposite, either losing oxygen or gaining hydrogen. In the figure at the bottom, I show two major oxidation reduction pathways, starting with ethane, an alkane, which is essentially the most reduced organic molecule. We can oxidize going to the right. Right, so we're oxidizing here, and what's happened? We go from an alkane to an alcohol, and we gained an oxygen. We can oxidize again to an aldehyde, and that involves removing two hydrogens. Oxidizing an aldehyde to a carboxylic acid again involves gaining an oxygen. Alright, so in the oxidation direction, we're either losing hydrogens or gaining oxygen. Of course, if going from right to left is oxidation, going from right back to left is reduction. So those two are just in opposite directions. Another pathway of oxidation from an alkane is to go down here to an alkene, right? So when we go to an alkene, we're oxidizing and we're losing two hydrogens. If we oxidize again, we get to an alkyne, which also involves losing two hydrogens. So going from alkanes to alkenes to alkynes are oxidation. Going the opposite direction from alkyne to alkane is reduction. Before we look at some specific reactions, let's just look at some common reducing and oxidizing reagents or conditions. Reductions take place under three types of conditions in organic chemistry. Each involves a net adding of hydrogen, or H2. So the difference in each of these methods is just how the H2 is delivered. The first method is called the dissolving metal reduction. In this case, two electrons are supplied by the oxidation of sodium metal. So that's the dissolving metal. And two protons are supplied from ammonia. So these two protons and these two electrons gives us net H2. Another way to reduce organic molecules is to use a combination of hydride. So here's H minus and proton H+. So if we mix H- and H+ together, we get. There are several ways to deliver the hydride, and I'm showing two here. The reagent on the left is called sodium borohydride. Okay, and this is considered kind of a weak hydride reducing agent. The agent on the right over here is called lithium aluminum hydride. And it is a very strong hydride reducing agent. Like sodium borohydride, it's able to deliver H-. The last method is called catalytic hydrogenation, and this is where a molecule just reacts directly with H2. Most times this reaction doesn't happen spontaneously, but has to be done in the presence of a catalyst, usually a metal catalyst like palladium, platinum, or nickel. Oftentimes the palladium is adsorbed onto charcoal or graphite, so it's oftentimes called palladium on carbon. Oxidizing agents come in two different types that we're going to look at right now. The first involve peroxides, and so these are molecules that have oxygen-oxygen bonds. The first general type, or the main general type we're going to look at, is called a peroxy acid. So the structure looks very much like a carboxylic acid, but it has an extra oxygen. It has an oxygen-oxygen bond. Two examples of peroxy acids are peroxyacetic acid and metachloroperoxybenzoic acid. So, and this is referred to oftentimes as MCPBA. So if we're going to do reactions, I think just writing it like this with an R group, there's many different peroxy acids that can be used, but the important part is that functional group. The second type of oxidizing agent has to do with oxygens that are bound to metal, or metals bound to oxygen. And these metals tend to be high oxidation state metals. Okay, for example, chromium reagents are very common. And so chromium in this case has a 6+ oxidation state. And so it's very high, so it can be reduced while an organic substrate is oxidized. This is a very strong oxidizing agent. A related compound, this one just to the right, which looks a little more complicated, is called pyridinium chlorochromate, or it's just referred to as PCC. This also has a 6+ oxidation state on chromium, but this combination generates a rather weak oxidizing agent. Other oxidizing agents that we might see are potassium permanganate. The manganese is 7+. Silver 1 oxide has silver just in the 1 oxidation state, or osmium tetroxide has the osmium in the 8+ state. So many times in these, the metal is a very high oxidation state, so it can receive electrons and be reduced while we're oxidizing the organic species.